Welcome to episode 3 of the Audio Guide to the Galaxy Season 2, a podcast put together by those of us at Scitech to help you keep connected with our wonderful night sky. My name is Leah, one of the presenters in the Scitech Planetarium, and tonight we will be gazing close to the horizon to spot some interesting objects. First, getting up close and personal with the planet Mercury, and then finishing up with the large scorpion in the sky, Scorpius. This recording is timed to take place at 6 p.m. on any night of the week starting the 12th of June, so you can take this out whenever the time and weather suits you best. Just make sure wherever you are, you have nice clear views of both the western and eastern horizons. And one final thing. Make sure you are nice and rugged up in warm clothing. Even if you have clear skies overhead, it is going to get pretty cold. So please make sure you are staying nice and warm as you are stargazing. On that, I'm hoping you are now outside and ready to go. So let's begin. Let's start by looking towards the west. Remember, the easiest way to find west is to face the direction the sun has set. Speaking of sunset, you might have noticed that we are starting at the slightly earlier time of 6 p.m. tonight. Looking up, you can spot some of the brighter objects alight in our sky, but along the western horizon, you can also see a faint glow. This is the last remnants of the sun's light for the day. Even though the sun set over 40 minutes ago, its light is still bouncing around and reflecting in parts of the atmosphere. And this allows us to see the faint glow of the sun long after it has set. Being the stargazing experts that you are, though, you may think it a little bizarre that we are starting so early. How can we see anything clearly without a completely dark sky? That is an excellent question, and generally speaking, you are absolutely correct. Stargazing is best done with dark skies. But sometimes you need to make an exception if you want to spot some special objects. And tonight, we are making an exception in order to spot the smallest planet in the solar system, Mercury. To spot Mercury, you need to make sure that your view of the western horizon is completely clear, as the planet is lurking very close to the horizon. If you have something blocking the way, whether it be a tree, a fence, another house, then I recommend moving your position to get a better view. Once you are in position, you should be able to see a bright, shining object almost directly west, with an altitude of roughly 20 degrees. And that means you should fit approximately one hand span between the horizon and this bright object. Now, as convenient as it would be for me to say this object here is Mercury, unfortunately it is not. But it is a familiar object for those of us who listen to Season 1, as it is the brightest star in the night sky, Sirius. Sirius will be our guide tonight, directing us to Mercury. To find the small planet, draw a line from Sirius down to the horizon. From this point, measure out 40 degrees along the horizon towards the north. The easiest way to do this is with your arm out at full stretch. Place your left pinky on the starting point and then measure out roughly 1.5 handspans along the horizon towards the right. From here, just a little bit above the horizon, approximately 3 finger widths above, you should see a faint, sharp point of light. This is the planet Mercury. Now, for those of you who got the chance to spot Venus in the sky, you might find Mercury a little underwhelming. It is by no means as bright as Venus. This is due to two very important facts: that it's smaller and much further away. Venus is the closest planet to the Earth and also has an incredibly thick atmosphere that's quite reflective of light. On the other hand, Mercury at the moment is 104 million kilometers away from the Earth. making it 60 million kilometers further away than Venus. It's also 2.5 times smaller than Venus and lacks a smooth reflective atmosphere. Instead, it has a rough surface marked with countless craters. This all makes for a planet that appears quite faint in our sky at the moment. Even though that may be the case, it's still quite special to be able to see the planet Mercury, because for much of the year, it's hidden from view, commonly nicknamed the elusive planet. The key difference between Mercury and most other planets in the solar system is its position. Mercury orbits the Sun inside the Earth's orbit. This one difference has a dramatic effect on how this small planet appears in our sky, and the reason why it is so elusive. For example, it means that whenever we look towards Mercury, it's always going to appear close to the Sun, either just before sunrise or just after sunset. Its orbit also means that the opportunity to spot Mercury only comes around 6 times a year. But each time Mercury appears, it only stays in the sky for 2 to 3 weeks before it disappears from sight again. The reason why this window is so small is because you need to wait for Mercury to reach maximum angular separation from the Sun. This just means the greatest distance measured between Mercury and the Sun in the sky. It can sound a little confusing though, so let's imagine watching Mercury's orbit of the Sun standing on a stationary point in space that is in the same plane as Mercury. In other words, we're not watching it from above, but from the side. As Mercury traces out its orbit around the Sun, to us it just looks like it's going back and forth along a straight line with the Sun in the middle. At the starting position, when Mercury is in front of the Sun, we can't see the planet because it's hidden by the Sun's glare. As it continues along its orbit in a clockwise direction, to us it would look like the planet is moving towards the left. Eventually, it will escape the bright glare of the Sun and become visible for us to see. But Mercury doesn't stop orbiting, so it will reach a point in its orbit where it will stop moving towards the left and instead head back towards the right, towards the Sun. This point, this is the peak, where from our perspective it appears to be at its greatest distance from the Sun and the perfect position for us to see it clearly. This is the maximum angular separation. As Mercury continues along its orbit, it will disappear from sight, this time hiding behind the Sun. Soon enough though, it will appear on the other side of the Sun, reaching its peak on the right-hand side of our line and escaping the glare again, allowing us to see it. These two extreme points in its orbit are when we are able to see it on Earth. But as I said, it only lasts in this position for 2 to 3 weeks before it is hidden from view again. This is thanks to the fact that Mercury has such a quick orbit, only 88 Earth days in total. If you do the maths though, it means you only have to wait roughly 44 days for the next window to appear. Give or take a little, thanks to the fact that the Earth is also moving in its orbit too. Despite the limitations of viewing Mercury, we have discovered a lot about this small planet. Mercury looks a lot like our moon, with pictures of Mercury often mistaken for the moon. Its grey surface also covered in a multitude of craters. Unlike the Earth, there is no geological activity on Mercury, so as the surface is bombarded with meteors, there is no regeneration of the surface to cover the impact craters. Much like we have learned with the moon, however, this gives us great detail into its past. In particular, we know that Mercury is quite a dense planet with a large iron core, taking up over 60% of its volume. This leaves scientists to believe it once had a much thicker rocky surface, but some sort of event caused the planet to lose large amounts of rock in its early past, leaving it to be the small, dense planet it is today. Some theories include a massive collision between Mercury and an object 1/6 its size, or that perhaps the intense conditions of the Sun, before it had finished forming, vaporized the outer layers of rock from this closed planet. While that remains a mystery, there is still a great deal of the planet that we do know. One of the most striking differences of Mercury compared to many other planets in the solar system is that it has an extremely thin atmosphere. While the Earth is the only planet with an atmosphere that is perfect for us to breathe, other planets like Venus and Jupiter have incredibly thick atmospheres. The lack of a sufficient atmosphere stems from two reasons. The first being that it is so very small that it doesn't have enough gravity to hold on to an atmosphere. And the second reason being that it is so incredibly close to the Sun that the few particles left on the atmosphere get heated to high temperatures, giving them enough energy to escape the clutches of the planet. This plays out in an interesting way on the surface of the planet, a tale of two extremes. The side facing towards the Sun receives the full blast of the Sun's energy. So during the day, temperatures on Mercury can soar to 430 degrees Celsius. Yet, because the atmosphere is so thin, it doesn't hold on to that heat and spread it around the planet. Meaning on the side facing away from the Sun, the nighttime side, temperatures can get as low as minus 180 degrees Celsius. And to make things even more bizarre, one Mercurian day can last 176 Earth days, thanks to the fact that it takes 55 Earth days to rotate on its axis, yet orbits the Sun in 88 days. So it is rotating much, much slower than it is orbiting the Sun. If you were living on Mercury, one day on this planet would mean the equivalent of 3 Earth months in extremely hot temperatures, and then another 3 months in extremely cold temperatures. In the meantime, the planet has orbited the Sun twice, so you would have already had 2 birthdays in the space of 1 Mercurian day. Mercury is a strange little world, and so very different to the planet we call home. As fascinating as Mercury is, I want to now direct our attention to the exact opposite direction, towards the eastern sky. Just starting to grace our skies as we embark on the winter months is the mighty constellation of Scorpius. Scorpius, otherwise known as the Scorpion of the Sky, is a spectacular constellation to spot and one that many can find easily enough. In fact, as you look towards the east, I wouldn't be surprised if you've already started to spot some of the stars that make up this special constellation. Let's work together though to map out the entire constellation. We'll start with the brightest star known as Antares. It is a bright red star that lies in the heart of the Scorpion. Facing directly east, you should see that bright red star sitting roughly 23 degrees above the horizon, or 1 handspan above. Keep in mind though that in the metro areas of Perth we have the hills towards our east, so Antares may appear a little closer to the horizon, perhaps only 3 or 4 finger widths above. Either way, I'm confident you will spot it easy enough thanks to its colour and brightness. We will talk more about Antares in a little more detail very soon, but first let's find the rest of the stars that belong to the Scorpion. To find the head of Scorpius, you will see 3 bright stars just to the left and above Antares. Together, the 3 stars almost form a straight line, and you should fit roughly 3 fingers between Antares and these stars. The middle of these stars is Jubba and resembles the head of the Scorpion. The name Jubba is a traditional name that originates from the Arabic word for forehead. The 2 stars to either side of the head star resemble the large claws of the Scorpion. In the time of the ancient Greeks, the claws were actually represented by a whole separate constellation above Scorpius. In modern times, these claws morphed into the constellation of Libra, and instead Scorpius had to be content with 2 bright stars to resemble its claws. The star to the right goes by the name of Fang, a star system nearly 600 light years away. The star to the left, on the other hand, has 2 names: a crab, meaning the scorpion, and Graphias, Italian for the claws. The reason it has 2 names is because it is a multiple star system. When looking through a telescope, there appears to be 2 separate stars orbiting each other, a binary system. With further investigation, however, it was discovered that this was not correct. It wasn't a 2-star system, but in fact a 6-star system. 2 sets of 3 orbiting each other. To our eyes, though, it appears as a single star. So I'll let you decide what name you want to call it. With the top half of the Scorpion mapped out, the bottom half is much easier to find. From Antares, in the opposite direction to the head and claws, you should be able to fill in the curl of the tail. The tip of the tail is marked by a star named Shola. The name comes from the Arabic word for raised tail or sting. You can find Shola easily enough by drawing a line from Jubba, the head of the Scorpion, down to Antares, and continuing the line along this direction for roughly 17 degrees, or just a little less than 1 handspan. Shola is a bluish-white star in colour and the 2nd brightest star in this constellation. From Shola, you should be able to draw out the curl of the tail back up to Antares. This completes the constellation of Scorpius. I often like to ask people if they think it looks like a scorpion or not, with many saying that it looks more like the letter J, or even a fish hook. What do you think it looks like? With the entire constellation mapped out, let's get back to the heart of it, the star Antares. As you can see, the star shines bright red in colour, much like another famous object that can be found in the sky, the planet Mars. Often this star gets confused for Mars, something that was common in ancient times as well. We know this from its name, Antares. You see, Mars is the Roman god of war, but in Greek, this god goes by the name of Ares. So the name Antares translates to not Mars, or the opposite of Mars. Interestingly enough though, this star is a powerhouse. It is a red supergiant, heading towards the final stages of its life. The star is estimated to be between 700 to 800 times bigger than our Sun, meaning if it were in our solar system, the star would reach out to the asteroid belt beyond Mars. It also shines over 10,000 times brighter than our Sun. And one day, this star will reach supernova. With the fuel running out to power the star, it will explode with tremendous force, sending waves of material out into the galaxy. It is difficult to predict when it will go supernova, but when it does, it could shine as bright as the full moon. That is how powerful these explosions are, all this energy trapped within this star. I'd say Antares can definitely match the great god of war. Before finishing off for tonight, I would like to point out one final thing. While seemingly unconnected, other than the fact that they both lie close to the horizon at the moment, the constellation of Scorpius and the planet Mercury do have one thing in common. They are both astronomical representations as messengers, or messages from the gods. To the east we have Scorpius. Scorpius is depicted in Greek myth as a message sent from the gods to curtail excessive pride. The all too familiar constellation of Orion represents the Great Hunter. But Orion knew of his greatness in a way that made him terribly arrogant, a trait not appreciated by many of the gods. One day his boasting became too much to bear, and as punishment, a skilled scorpion was sent to destroy him. The battle between the two was magnificent and even caught the eye of Zeus. In the end, the scorpion bested Orion with a quick strike of its sharp sting. Orion learnt his lesson, that indeed he was not the greatest hunter to roam the earth. Zeus, moved by the lesson he learnt, placed both among the stars, reminding everyone who looks up that pride will get you nowhere. And these two constellations are placed on opposite sides of the sky, meaning you don't get the chance to see them both in the sky at the same time. As the myth goes, it is because even now Orion cannot bear to face the great scorpion who beat him. So he sits in the sky as the scorpion starts to rise. To the west, we have Mercury. Mercury, whose name comes from the Greek god Hermes, and he was more than a single message sent by the gods. Instead, he served as the great messenger of the gods. With his winged sandals, he was able to move swiftly to pass on messages to all those who roamed in both the divine and mortal worlds. He not only passed on messages, but he delivered the souls of the dead to the afterlife, playing such an important role in the mythological world. Messengers play vital roles. Without them, we learn nothing. While we don't live in the times of ancient mythology, every time we look up to the sky, we see the messages of the universe written on waves of light. But our connection to the universe doesn't stop there, because we too have our own messengers, spacecraft that go off into the depths of space to learn more and deliver messages back to us. In fact, in 2004, we sent a spacecraft called Messenger to Mercury so we could learn more about this little planet. It took 7 years to reach Mercury, but by 2011, it was taking its first images of the surface of the planet. In total, it orbited Mercury 4,100 times and gave us a complete map of the surface. Throughout its mission, it gave us the chance to learn more about Mercury than we could have hoped for, and more than we could have ever learned stuck here on Earth. In fact, thanks to Messenger, you can even explore these maps of Mercury on Google Earth. Messenger truly was a planet pioneer. Its mission finished in 2015 though, but since, there have been many other messengers we have sent out into the solar system, so we can learn more about this part of space we call home. That brings us to the end of Episode 3, Season 2 of Audio Guide to the Galaxy. Tonight we got the chance to make the most of the small window to see Mercury, spotting the little planet that holds many mysteries. We then turned our sights to the east to see the great Scorpius rise in the sky. Between the two, we can be reminded of how important messengers are to our expanding knowledge of the cosmos around us. Good night, everyone, and remember you can find the universe just outside.